So far, we've consumed lists of numbers and produced images and numbers. But lists can be composed of any type. Let's create a data definition for winning and losing at games. Specifically, we will say that a game outcome is a string, one of either win, tie, or loss. So this is an enumeration. The interpretation of our enumeration is we get 1 point for winning games. Let's be a little bit clear with that punctuation. For winning games, lose 1 point for losing games, and 0 points for tying games. And then we can create a data definition for a list of games. So we say that a list of games is either empty or a cons game outcome list of games. We're allowed to use game outcome because we've previously data defined game outcome as an enumerated string, either win, tie, or loss. And we're recursively using list of games. Let's give a quick interpretation. A series of games played over a season. So that's what our list of games is representing. We next need to make some examples. So we say that no games is the empty list. We define season 1 as being the cons list of a loss, followed by another loss, and then in a crippling ending, we have another loss. So that's season 1. In season 2, we can say that we got a little bit better. We start off with a win. And then maybe just for mixing it up, we lose, but we come back and win it by the end of the season. So it's a good second season. And then the third season ends up being shorter than all the others. And we'll say that it had a tie and another tie. And then an empty. Great. So now we have 4 examples to build off of. If we want to know the final score for a season, we can create a function named scoreGames. It won't be that different from our previous function where we were adding together a bunch of numbers, but now we're trying to add together a bunch of game outcomes. So we'll define scoreGames as a function that consumes a list of games, and that produces a number. Consumes a list of games representing a season and adds together their scores to produce the final score. So we define scoreGames as a list of games using our abbreviation, leaving the body blank for now, like good programmers. And then we make our check expects, saying scoreGames of the no games example is worth 0 points. The check expect scoreGames of season 1 is worth a total of -3 points. We had a very bad season. And then scoreGames of season 2, we did a bit better. We got 1 point overall. And then we check expect of our abbreviated season, season 3, we had 2 ties, so it ends up being 0. So this is getting a pretty good coverage of cases. Let's go back up and write the body of our function. We put in our template. We have an itemization here, so we need 2 clauses. The first clause asks if a list of games was empty. If so, we'll do something. Otherwise, we have to ask if it's a cons, and if so, then we'll do something different. In that case, we'll end up using the first of the list somehow, and the score games of the rest of the list of games. So we end up using this so far. We need to find some way of combining these two. We also need to fill in the blank here. In the case of an empty list, of not having played any games, we said that it returns 0. So our base case is also our empty case. When we have the first game, which is a number, and the sum of the rest of the games, that's also a number, we need to end up adding them together. But we can't just add up a list of games because a game is not a number. It is a game outcome. So we'll need some way of converting that. We're going to say that we have a function called scoreGame. And if you've been paying attention, you know that that's not true. We have scoreGames, but not scoreGame. So, although we've written this function and it's all done, we're not actually done overall. We still need to define our scoreGame function. So we'll do that next. We go down here and we say that scoreGame is a function that consumes a singular game outcome and produces a number. Consumes a game outcome and produces the associated score change. We define the header, score game consumes an outcome, and we don't know what it does yet, but we do know the checking specs. And there's only 3 cases. It's either a win, in which case we got 1 point. It could be a tie, or it could be a loss. In the case of a tie, we get 0. In the event of a loss, we get -1. And this leads to a very clean and easy cond. We know that we've got an enumerated type. It's got 3 clauses. The cond should have 3 clauses. And each one will ask, what kind of string is it? The first one is that it's a win, in which case we return 1. Second one says that if it's a tie, we'll return 0. And if it's a loss, we'll return -1. At this point in time, we can try running our code and seeing how we've done. Hopefully, all of our checking specs will pass, which it seems they do, so all is well. So notice there, we ended up writing a function, score game, that we could apply to each element of the list. So we had score games and score game. We made it up. We kind of decided that we needed it halfway through. We kept writing this function, finish it off, pretending like it existed, and then went ahead and defined it once we were done.